25 degrees Celsius, the gas in an aerosol can is under a pressure of 3 atmospheres. Atmospheres is just another unit to measure pressure in. Okay, so in terms of the units that you should be using to measure pressure, there is a standard unit that we always use to express everything. For temperature, we call that the SI unit, by the way. SI stands for standard interval. Okay, the acronym for SI isn't so important, but all we're concerned with, SI unit is just the unit that you normally do your measurements in, okay? And the way we like to express it, just to keep everything constant. Sometimes you'll get units that are different, you just have to convert it over. So SI unit for temperature is kelvins, and SI unit for pressure is pascals. Sometimes you'll get it differently, but pascals is what we prefer to use. But in this question, we get told that it's 3 atmospheres at 25 degrees Celsius, and we get told that we get asked what is the pressure in the can if the temperature increases to 845 at constant volume. Okay, so when you get questions about gases, there's a few different things you want to identify. What I've told you is that these gases, for each of the different scientists, always hold one variable constant. Okay, so in this case, for Gay-Lussac's law, it's at constant volume. So if the question tells you that it's at constant volume, then that gives you the hint that you're supposed to be using Gay-Lussac's law. Okay, and since it's talking about change, because it said it was originally at 25, then went to 845, we need something that can relate. We need an equation that can relate two different points together. So in this case, we're not using that equation up here. We're using this one, right? Well, sorry, I shouldn't have crossed that one out. We're using this one right here. We get P1 on T1 is equal to P2 on T2. What's my P1 value?
Would that be the 3 atmosphere?
Yeah, so that's the original one that we have, because we get told that the temperature later increases to 845. So our original temperature and pressure is 3 atmospheres. And what's our original temperature?
25 degrees.
25 degrees Celsius, good. What did we say earlier about temperature? Do we like to express it in Celsius, or do we like to express it in kelvins?
In kelvins.
Kelvins, good. Do you remember how to convert from Celsius to Kelvin? What did we add?
We plus it by 273.15.
Good. So this is going to be 25 plus 273.15 Kelvin. I'll explain in a minute why we're still able to use 3 atmospheres. It has to do with how we do our unit conversions regarding pressure and temperature. But in this case, P2 is a thing that we're looking for, because we get asked for what is the new pressure of the gas. Sorry, what is the new pressure in the can of the gas? And what's our T2?
The T2 is 845, so it'll be 845 plus 273.15.
845 plus 273.15, beautiful. And then P2 is going to be, just rearranging this equation, it's going to be 845, move that over, so that's going to be 3 atmospheres times, so let's just keep our units just so that we can keep track of it. So 3 atmospheres times 845 plus 273.15 Kelvin, all on 25 plus 273.15 Kelvin. So my Kelvins are going to cancel out, one's at the top and one's at the bottom, and I get left with atmospheres. So what's my P2 value?
3.76035.
3.76035 atmospheres, good. And then from the question, how many significant figures do I round off to? I have 3 different numbers there. What's the lowest sig fig?
2.
2, good. So that's going to be 25 degrees Celsius. So what is my final answer going to be?
3.8.
Good, 3.8 atmospheres, and that's going to be 2 sig figs. I'm going to put that in brackets just to let my marker know that I've rounded it off correctly.